we sort of talked about multiplicity without using the word multiplicity. So think about this. If you think of linear equations, okay, now if you go to the bottom of the page where you have 6 boxes, now could you go ahead and draw 6 straight lines? Okay, so we did something called multiplicity, but without using the word multiplicity. So to get you started, think about this. Do you still remember how to draw quadratic equations? Like the parabola. Remember you can draw parabolas like this, right? So these are so-called the roots. So these are so-called the roots, and there's no square or anything. It's just regular, like x plus 3 or x minus 2. So we would just have the root and have a regular passing through like this, or a regular passing through like this. There's no bounds of any kind. There's no weird turn of any kind. It's just passing through. But then you also saw some kind of quadratic equation that goes like this, right? It bounces on the x-axis. That's because you have something like x plus 3 parentheses square. So whenever you see some kind of square in the numerator, that's when the x-intercept would have a little square thing. That's when you see the bounce, the so-called bounce, because there is no sign change, okay? Again, whenever there's a bounce, it simply means that there is no sign change. So it can bounce on the positive side or it can bounce on the negative side. That means there is simply no sign change. And now, do you still remember how to draw a cubic function, the x cubed function? Do you remember that when you draw the x cubed function, it goes like this, the little S shape, that kind of turn. So if it happens to be a cube in the numerator, then as it approaches to the x-intercept or the root, it will go something like this to the positive side, or it goes like this to the negative side. So again, there is nothing really new that we are trying to show you here. It's more of a show and tell and say, hey, you've got something that you need to take care for. Okay, so based on these 6 looks, let's look up right here. All right, let's look up right here. Can you see this square? So what does it mean when we have a square right here? Well, here we go. We are going to draw the graph from here, and then it's going to come down, and it's going to hit the x-intercept. But because of the appearance of the square, there will not be any kind of sign change, which interprets as a bounce. So it'll bounce off the x-axis, and then it will lean closer to the horizontal asymptote. Okay. And the reason we know that the graph would start from the positive end next to the vertical asymptote is because the other side of the vertical asymptote goes to the negative side, and there's no square of any kind in the denominator, so that means there will be a sign change, so they would approach from opposite directions. And then same thing onto the graph next to it. So if you see the square right here, we have x-intercept at the origin. So what's going to happen is it's going to go up and then it's going to come back down. Okay, it's going to go up, it's going to come back down. And that's how you know. That's how you know it is, how you know it's going to bounce because of the appearance of the square.